Hello, merman scientists. It's me, Tater, the science dog, and I'm here to talk to you about extreme weather. Now, when it comes to extreme weather, we're going to talk about three specific types. We're going to talk about tornadoes, we're going to talk about hurricanes, and we're going to talk about thunder and lightning. So, first, I want to talk about tornadoes. They're one of the most violent and powerful types of weather. They consist of a very fast, rotating column of air that usually forms a funnel shape. They can be very dangerous as their high speed winds can break apart buildings, knock down trees, and even toss a car into the air. Most tornadoes form from thunderstorms. You need warm, moist air from the south and cool, dry air from the north. When these two air masses meet, they create chaos in the atmosphere. A change in wind direction and an increase in wind speed will create this spinning effect in the sky. Tornadoes can vary widely in size. A typical tornado in the United States is around 500 feet across, but some may be as small as just a few feet across or nearly 2 miles wide. The wind speed of a tornado can vary from 65 to 250 miles per hour. But lucky for us, big tornadoes like those don't happen in Los Angeles. Most of the tornadoes in the United States occur in an area called Tornado Alley. Tornado Alley stretches from northern Texas to South Dakota and from Missouri to the Rocky Mountains in Colorado. Our next type of extreme weather is going to be hurricanes. A hurricane is a large rotating storm with high speed winds that forms over warm waters in tropical areas. When warm, moist air over this water rises, it's replaced by cooler air. The cooler air will then warm and start to rise, and this cycle causes huge storm clouds to form. If there is enough warm water, the cycle will continue and the storm clouds and wind speeds will grow, causing a hurricane to form. The winds inside a hurricane have been recorded to be as fast as 200 miles per hour. When hurricanes strike land, they can cause huge amounts of damage. Most of the damage is caused by flooding and storm surge. Storm surge is when the ocean level rises at the coastline due to the power of the storm. Hurricanes also cause damage with high wind speeds that can blow down trees and damage homes. Lucky for us, hurricanes don't form in the ocean near Los Angeles. The Pacific Ocean is just too cold. But on the opposite side of the United States, near the Atlantic Oceans, hurricanes usually occur between June 1st and November 30th each year. This is called hurricane season. The last type of extreme weather I want to talk about is thunderstorms and lightning. When warm, moist air rises quickly, a thunderstorm can form. Thunderstorms bring high winds, heavy rain, lightning, and sometimes even hail. Thunderstorms appear all around our planet every day. They can form at any time, but most often in the afternoon and evening during the warm seasons. Inside a thunderstorm, sometimes you can find lightning. And lightning is a powerful blast of electricity that can form in thunderstorms and strike the earth with a powerful force. In order for lightning to occur, first, high winds within a thunderstorm cause ice and water particles to bump against each other at high speeds. This is an example of friction. Friction happens when two or more things up against each other. All of that friction from all of those collisions between ice and water will create an electric charge. After a while, the whole cloud fills up with electrical charges. Those charges need to escape, and eventually, zap, lightning strikes. Have you ever rubbed your feet across the carpet and then touched like a metal door handle? If so, then you know that you can get shocked. See, lightning works in the same way. All right, Merman scientists, Mr. Zeri here. Tater, the science dog, had to take a break. But now that we've learned more about lightning, how lightning strikes, why lightning strikes, we've learned about friction. And I want to do a little experiment with you guys where we sort of get a firsthand look at friction and we can create our own electricity using friction. We're going to create static electricity. So all we need for this little experiment is our balloon. What we're going to do is we're going to blow our balloon up. If you're having trouble blowing your balloon up, try to get some help. You don't need to tie your balloon necessarily. We just need to get it inflated. Okay, once we've got our balloon inflated, we're going to rub it on our head for about 10 seconds. We're going to slowly move it away and we're going to see what happens. So what's happening? So when you rub the balloon on your hair, you're giving it a small electric charge. And what's actually happening is you're rubbing tiny particles called electrons from your hair and onto the balloon. This gives the balloon a slightly negative charge and your hair a slightly positive charge. And opposites attract. So these charges are trying to stick back to each other. And this is why when you move the balloon away from your hair stands on end and tries to go with it. Another cool thing you can do with your static electricity is you can grab a tissue paper or toilet paper and you might be able to actually attract it and stick it to your balloon. See if I can get it. Give it a good rub. Get those electrons onto the balloon. The balloon is going to have a negative charge and it's going to try to get the positive charge from off of this tissue paper. It works really well too if you rip your tissue paper and you've got a really small piece. It's really light. You can pull it right off your hand. Pretty cool. So that's friction. That's static electricity. I hope you guys enjoyed it. I look forward to the next video. Bye, everybody.